Hi, welcome to Sachu Study Tech. Today topic is Bellman-Ford algorithm. So if any graph consisting of negative weight, so you cannot apply the discussed algorithm. In previous video where we have discussed what is the drawback if that graph any edge consisting of negative weight. Now we can solve that problem by using Bellman-Ford algorithm, which is also a greedy method. So this algorithm solves the single source shortest path problem, directed graph. So here it can use the only directed graph. This Bellman Ford design for the directed graph. So in which the edge weight may be negative. So moreover, this algorithm can be applied to find the shortest path if there does not exist any negative weighted cycle. So what is the negative weighted cycle? Later we can discuss. So what is the drawback here also Bellman Ford. So what is meant by relaxing? Go on relaxing all the edges n minus 1 times where n is the number of vertices. Relaxation means updating the shortest distance to node if a shorter path is found through another node. So here if d of u plus cost of uv less than d of v and d of v equal to d of u plus cost of uv. So what is the time complexity? Here it is Bellman for time complexity. In best case, that is big of e when distance array after first and second relaxations are same. You cannot solve anything, simply can stop further processing. Average case and worst case is big of v into e. So space complexity of this Bellman Ford algorithm is adjacent list. You can use the adjacent list. Here it is big of v plus e. Adjacency matrix, here it is big of v square. Now we can discuss how we can solve this. So you can see this is the example graph. So here this graph also having some negative weight. So this is the negative weight, here also negative weight. Negative weights is there. So you cannot apply the discussed stress algorithm. You know already you can discuss what are the drawback in the discussed stress. So that problem you can solve here also. If any graph consisting of any negative weight, in that case also you can apply the Bellman Ford. You can find out the distance from source vertex to all other vertices. The first step, find the shortest path of the above graph. The first step is note down here. So what are the edges is there, you can note down here. So a to b is there, a to b and a to c, a to d. So like that you have to, so b to e, so you have to write a to b, a to c, a to d. So a is completed. Now we can see b to e. So that is the b to e and c to e, and there is no c to f, c to d, then c to e. Now we can see d to f. So d to c is there and d to f is there, you can note down it, and e to f is there, e to f, and c to b is also there, c to b. So now you can note down here, like that you can note down. Any order you can note down a to b and a to c, a to d, and also. So how many times you can iterate this? N minus 1 times. N minus 1 times the same procedure you can apply. What is meant by n? N is the number of vertices in the graph. Here 4 plus 2 6 vertices is there, that is you can iterate up to 5. Then you can find out the shortest distance from source vertex to all other vertices. If it is if sixth iteration also you have to change any weight of the or cost of the vertex, so it is not provide the solution. So now we can discuss. So initially I am a is a consider a is the initial vertex and remaining all vertices set to infinity here, set to infinity. This is the first step. This is the first step. Second step is, so a to b. So a to b, what is the cost a to b? So a to b is 0 plus 6. You know the relaxation here, it is d of u plus cost of uv is less than d of v. If it is true, then you can update the d of v, that is d of u plus cost of uv. You can update it. Here it is For example, here it is u, here it is v, and d of u 0 plus cost of uv, cost of uv is 6, 0 plus 6, so that is equal to 6, 6 less than d of v, d of v is infinity, so d of e is infinity, so that's why 6 less than infinity, the condition is true, then you can update the d of e, d of e equal to d of u plus cost of uv, that is 6, so you can update here, it is a 6. Like that, how to find out the distance from one source vertex to all other vertices. Now we can see initially it is now. So here the first step is it is 0, remaining all vertices are infinity, infinity, here it is infinity, here it is also infinity, here it is also infinity. So now, so A is the source vertex, to have to find the distance from source vertex to all other vertices. So how many times you can iterate? N minus 1 times. So that is equal to 6 minus 1, that is equal to 5. So in 5 iteration, first iteration, in first iteration. So A to B, A to B, so A to B, here it is 0 plus 6, 6 is there, so infinity, so we have to update it, 6 is the minimum. And A to C, A to C, A to C is 0 plus 4, so 4, here it is infinity, 4 is the minimum, we can update it. Next A to D, A to D, A to D, so here the A to D is 0 plus 5, 5 is there, so 5 is the minimum, so we can update it 5. And here it is B to E, B to E, so B to E is 6 minus 1, that is 5, already infinity is there, 5 is the minimum, we can update it. Next C to E, C to E is 4, C value is 4, cost of C is 4, 4 plus 3, 7, here 5 is there, so 5 is the minimum, leave it. And D to C, D to C, so D to C, here the D value is, cost of D is 5, 5 minus 2, that is 3, so 4 is there, so 3 is the minimum, we can update it. And D to F, D to F, 5 minus 1, 4, but infinity is there, so 4 is the minimum, you can update it. And E to F, E to F, E to F is, it is a 5 plus 3, that is 8, but 4 is already there, so this is the minimum, leave it. And C to B, C to B is, here it is a 3, 3 minus 2, that is 3 minus 2, that is 1, so 6 is there, so 1 is the minimum, have to update it. So this is the first iteration is over. Now you can consider the second iteration, better to take the different color, so we have to easily have to identify. So this is the first step, we have to draw this diagram. Next second iteration, also we have to draw the next diagram. So now we can see A to B, A to B is 0 to 0 plus 6, that is 6, here 1 is there, so that is the minimum, leave it. And A to C, A to C is 0 plus 4, 4, but here 3 is there, that is the minimum, leave it. And A to D, A to D is 0 plus 5, 5, but 5 is also there, so leave it. And B to E, B to E, so 1 minus 1, that is 0, but here it is 5 is there, so 0 is the minimum, we have to update it, we have to update it. And C to E, C to E, and C value is 3, 3 plus 3, 6, already 0 is there, so that is the minimum, leave it. And D to C, D to C, that is 5 minus 2, that is 3, 3 already there, leave it. And E to F, D to F is there, D to C, it is 3 is the minimum, leave it. And D to F, 5 minus 1, that is 4, leave it. And E to F, so 0 plus 3, 3 is the minimum, so we have to update it E to F. And the C to B, C to B, it is C value is 3, 3 minus 2, that is 1, already 1 is there, leave it. So second iteration is over. We have to draw the second diagram. Now, is there any changes in this second step? So changes is there, that's why we can apply the next iteration. If there is no change in any iteration, there is no changes, there is no change of those particular vertices, then need not to iterate the next step directly, that is the result. So here there is changes is there in second iteration, that's why we can apply the next step. A to third step, third iteration, A to B, A to B 0 plus 6, 6 is the minimum, 6 is there, here 1 is also there, 1 is the minimum, leave it. And A to C, A to C 0 plus 4, 4, but here 3 is there, so leave it. A to D, A to D 0 plus 5, 5 is also there, leave it. And C to E, C to E is 3 plus 3, 6, but 0 is there, so leave it, that is the minimum. D to C, D to C 5 minus 2, that is 3, already 3 is there, leave it. And D to C, and D to F, D to F, so here 5 minus 1, 4, already 3 is there, that is the minimum, leave it. And E to F, E to F, that is 0 plus 3, 3 is also there, leave it. And C to B, C value is 3, 3 minus 2, that is 1. So this is the third iteration. In third iteration, there is no updation, so how to stop it? There is, if we can apply the fourth step also, there is no changes, so that's why. So what is the distance from here? It is a vertices, here it is distance. For example, here it is A to A is 0. For example, you can see A to B and A to C and A to D and A to E and A to F. So what is meant by A to B? That is distance is 1. A to C, the distance A to C, the distance is 3. A to D, the cost is 5. A to E, the cost is A to E, the cost is 0. A to F, the cost is 3. So how to get 1 here? A to B, so A to B here it is. So how to get 1? A to B, that value is A to C, A to C value is 3. So how to get A to C also? So here it is 5 minus 2, so that is equal to A to D, A to D and D to C, D to C and C to B. So A to D is 5, 5, D to C is minus 2, that is C to B is also minus 2. So here minus 2, you can add it, 5 minus 2, that is equal to 1. Next A to C, that is so A to C value is 3. So how we get the 3? A to C directly 4, but in A to D value is 5 and D to C value is minus 2, that's why it is 3. 5 minus 2, 3. And A to D, so A to D is 5, A to D is directly 5 here. A to D value is directly 5. And A to E, you can get the 0 here. It is, how can get the 0? So A to D the value is 5 and D to C the value is minus 2 and C to B the value is minus 2, C to B the value is minus 2, The cost of C to B is minus 2. Now B to E, the cost is minus 1. Now you can see 5 minus 2 minus 2 minus 1, that is 0. Here it is 0. Now here to F, that is 3. How you can get the 3 here? So you can see the same path, A to D, that is 5, and D to C, that is minus 2, and C to B, that is minus 2. Here B to E, that is minus 1, up to this it is 0, and E to F, that is 3. So the cost is 3. Now 5 minus 5 minus 2 minus 2 minus 1 plus 3. So that is 3. So this is the single source shortest path algorithm, Bellman-Ford algorithm, by using greedy method. Next class, what is the we can discuss what is the drawback in Bellman-Ford algorithm in next class. Thank you for watching this video.